Question 1. The linear function y is equals to 2x plus 3. So 1.1, we'll use the table below to calculate what? The values of y for the given values of x. So we simply just punch our calculator. Y is equals to 2x plus 3, then 2. Lagger x will put minus 4, of course, plus 3. After putting minus 4, then we'll go on and put minus 2 to get each value. So I'll just write them down in magnetical mean. So here we have minus 5, we have minus 1, we have 3, we have 5, and we have 7. 1.2, use the table to plot. Now we want to plot the point on the axis system below and connect the point with a straight line. Label graph as f, right? So let's try and plot. Okay, so we have minus 4 x. It meets with minus 5 y. Our points there. We have minus 2 x. It meets with minus 1. So we have our point there. Then we have 0 and 3. 3 for y, 0 and 3. Then we have 1 and 5. 1 and 5. And then lastly, we have 2 and 7. Right there. So let's plot. It's a straight line. Even though mine is not straight. And then we label it as F. 1.3. Complete the table below by swapping. What are we doing? Swapping the values of x and y. So the value star x now is minus, let's check. Now it's minus 5, minus 1, 3, 5, and 7. Values of y now is minus 4, minus 2, 0, 1, and 2. 1.4, use the table to plot. We are plotting on the same axis system as in 1.2 also. We're going to use this table to plot another graph and label the graph as an inverse. So now minus 5 here x with minus 5 here x, minus 5 here x, and minus 4 here y. Minus 5, minus 4, they meet somewhere there. Let me use a different color here. There. And then minus 1 here x and minus 2 here y, they meet there. Then we have 3 here x, 3 here x. Then we have 5 here x and a 1 here y, right there. Then we have 7 here x and 2, right there. So straight line. Hope is straight. Yeah, I think it's straight enough. Then we label it as inverse. 1.5. The transformation that takes place to obtain the inverse of a graph is a reflection in the what? In the line y is equals to x. Remember, inverse is the same as reflection, but the reflection of y is equals to x. And it's obtained by what? By swapping x and y. They change position. 1.6, write the equation of the inverse in the form of y. What was our original equation? Original equation is y is equals to 2x plus 3. They are not saying work it out. They are not saying determine. They are saying write it down. So no mkomba, I'm just showing it to you kuriva ikuminja. So x comes here, y goes there, and then 2y, we make it subject of the formula. We have x and then minus 3 because minus 3 jump in. Then we divide by 2. So our answer now here is y is equals to x minus 3 over 2. 1.7 is the inverse a function? Yes, it's a function. Give the domain and range of the following. So for our original equation, all x values are positive. Or you can say x element of, it starts from minus negative infinity to positive infinity. Then the range, all y's are real numbers. Or you can say y element of negative infinity to positive infinity to y. These are increasing graph. They increase from a negative infinity number to a positive infinity number. Then what about the domain? Domain yeah, inverse is still the same because the inverse of a straight line is also a straight line. X element of that. Let me use color 91. So we're fancy. We're fancy there. Green, yeah. So x element of that, y element of that. Let's just leave it like that. Let's say the infinity is too long. Question 2. Question 2. 2.1. The basic quadratic function. So we're completing the table. So y is equals to, where there's x, we'll put minus 3 and square. Then we'll get 9 here. Here we get 4, line 1, line 0. We have 1, we have 4, and we have 9. Those are our values. 2.2, we are plotting and we are labeling the graph as f. Let's try and plot. So let's see. Minus 3x is here. It meets with positive 9. They meet there. And then minus 2, is it minus 2? Yeah, minus 2, it meets with 4. And then 0 and 0 right there. Then we have 1 meet with 1. Oh, and C1. C minus 1 and 1 right there. 0 and 0 here. 1 and 1 again. And then 2 and 4, 3 and 9. Here we go. We'll label it as F. F now 2.3. Complete the table by what? By swapping different color for this, because this is going to be an inverse. So where we had x, it's a y and vice versa. So we have 9 here, we have 4, we have 1, we have 0, we have 1, we have 4 and 9. Here we have minus 3, minus 2, minus 1, 0, 1, 2, and 3. Yes. 2.4. Use the table to what we are plotting, and we'll label it as the inverse. This is inverse. So let's label our inverse. Now we have 9 as x, and then we have minus 3 as y, so right there. Then we have 4 as x and minus 2 as y there. Then we have 1 and minus 1 right there. And then we have 0 and 0. And then we have 1 and 1 there. Then we have 4. 4 and 2, they meet here. Then we have, did I miss something? 9 and what? And 3. So this is our inverse. F inverse. So our graph is like that. 2.5, 2.5. Almost done. 2.5, the domain. The domain of what? Domain of F. So all our x are positive. Or we can write x from negative infinity back to positive infinity. A domain, then range. We write it like that, especially if it's a positive quadratic. Y is greater than 0. Why? Because the range y is equals to x squared. We're looking at this invisible number here. We have nothing, we have 0. And our quadratic is positive, so the range is positive. The y's are increasing. There's no negative y's or y values. Then the domain of the inverse. Now, the inverse, yeah, graphly, it's not a function. So we have to restrict it. Now, I will not write none, even though the Agona domain, there's no domain for this inverse. So I won't write none, I'll just write them as if we've restricted them or we've changed them so that they have the domain. So the domain is including 0 and positive infinity, because it started from 0 inverse here. And then the range also 0 and infinity, just like that. 2.6. Why is the graph of the inverse not a function? Because it does not pass the vertical line test. Does not pass what? Vertical line test. What does it mean? So let's go back to the inverse. The vertical line test is like this. So when the vertical line test passes the graph twice, that graph is not a function. Yeah, 2.7, give the restriction. So there are restrictions that we have to give so that this function must be a function. Well, this inverse must be a function, so there's a restriction. The restriction is that we have to make the domain, okay, let me see how I can put it. We restrict the domain, the domain must be 0. What does it mean? It means we cut the function by half so that the vertical line test must cut that function only once. So we restrict that domain by cutting it by half. So you just write 0 to positive infinity. Oh, by the way, including the, yeah. And also the range we restrict it also by 0 and positive infinity. It's the same thing. Now 2.3, write the equation of the inverse. We're only writing it. No? Now let me show you the long way and then I'll just write it down. Original equations like that. So we swap x here, y there. Then we square root x is equals to y. So the equation now is y is equals to square root of x. That's the inverse. So we'll write it like this. Inverse is equals to square root of x for 2 marks.